Hello there. Today in this video I'm going to show you how to create a Graph API with Apollo Server, and I specifically want to demonstrate how you can add a Graph API to a stack with existing REST services. To save time, I've already started a monorepo here that includes two services in this packages directory, one called post and one called users. Then at the top level of this monorepo I have a start script here which will run the post service and a user service concurrently. So let's run that now and see what they do. As you can see here, the user service starts up on port 5002 and the post service starts up on port 5003. So if I try to navigate to the user service on port 5002 and ask for a specific user over a GET request, it will return an object with an ID, first name, last name, and post. And then if I make a GET request for a specific post, say for example P11, it will return an object with an ID, title, content, and read time. Another thing I want to point out here is that each time I make a request, I've set up the REST service to log a message in the terminal so that we know a request is happening. This will become kind of handy later on whenever we're making requests from a Graph service to these REST services. Okay, so that's everything I have in place. My goal today is to implement a Graph API that can sit between a client application and these two services that I've just shown you. This example is based on a post that I've linked in the description. That post talks about GraphQL and what it is, and it also highlights two key problems that GraphQL aims to solve. In summary, the first one is avoiding multiple round trips, and the second one is avoiding over and under fetching of data. So by the end of this demo, we're going to be able to request data from either of these two services over a single endpoint, and we're also going to have the ability to specify exactly what fields we want in the response. To get started, let's open a new directory in the packages folder alongside the other services, and we'll call it Graph. Then if I stop the services briefly and navigate inside that directory, let's run yarn init to start a new project. For this demo, we need to install a couple of dependencies. I'm going to use yarn add to install Apollo Server, Nodemon, Axios, and GraphQL, and we'll just wait for these to install. Okay, with those dependencies installed, we now need to add an index.js file to the graph folder. And then in the packages.json file, let's add a start script. You'll see here that I've used Nodemon. Nodemon is a dev tool which will execute the index.js file, but it will also take care of restarting that file if I make a file change, which is really handy because I don't have to do that manually every time. So I'll save that file, and then I want to show you in the package.json at the top level of the monorepo that I have a start script here, which is set up to run the post service, user service, and graph application concurrently. So in the terminal, let's run that now. With that running, you can see the post and user service are running successfully. And if I quickly drop a console log here in the index.js file for the graph folder, you'll see that that logs out as well. Okay, so that's everything we need to get started. We've got two services running in the background, and we've also done the setup work to write our Graph API and have it running as well. The first thing I'm going to do is drop some boilerplate here in the index.js file. And we're going to go through this line by line. On the first line, I've imported Apollo Server, and I've destructured the Apollo Server constructor and a utility called GQL. Then on the second line, I've imported the get function from Axios that we will use for making get calls to the REST services. This is where we'll define the schema. The schema that we type here will be parsed by the GQL utility. This is where we'll define our resolvers. And then here is where we create a new instance of Apollo Server using the Apollo Server constructor. And you can see that we pass in the schema and resolvers as an argument to this constructor. This then gives us an instance of a server, which we can call the listen function on. And of course, we can specify what port we want the service to run on. In this case, we're going to use port 5001. This listen function is a promise, so when it resolves, we can log a message out to say that the service is running. So if I try and save this file, you'll see that we get an error straight away, and this is because we haven't defined a schema for our API just yet. So let's drop in a schema. This schema is based on the example in my Medium post. It has two object types, user and post. The user field has an ID, first name, last name, and post. And then the post type has an ID field, title, content, and read time. One thing to note is the post field on the user type maps to an array of the post object type. Then here at the bottom we have a root level type query, which has one field called user, and this user field expects an argument of ID and maps to the user type. Okay, so if we save this file again, you'll see that this time the Graph service is ready and it's running on port 5001. So let's go to that URL now on port 5001, and you'll see that a tool called Apollo Playground appears. So in my Medium post I talk about how Graph APIs expect clients to contact them over a post request, but if you actually contact an Apollo server Graph API over a GET request, which is what we've done here in the browser, Apollo server is going to render this tool called Playground. And if you're familiar with Postman, it's quite similar. You can put a request here on the left hand side and execute it, and then you see a response on the right hand side. And it also does documentation, which it generates based on the schema of your API, which is really handy, but we won't go into that today. So let's start with a really simple query. To write a query, we just open curly brackets and specify the field we want from our API. So we know that in our schema here, we only have one field accessible at the top level, which is user. And the user field, it requires us to pass in an argument. So I'm going to pass it in within these brackets. So we need the ID, and the ID we want is defined here in quotes. I'm going to ask for user11, and because the user field maps to the user type, I can request fields on that type. So to do that, I open curly brackets again and just type out what field I want. So in my case, I'm going to ask for the first name and the last name. You'll notice that Apollo Playground is suggesting fields that are available to me on the user type, which is really handy. So if we click here, I can just complete the word. Then let's execute this query. Alright, so on the right hand side, we now have a response back from Apollo server, which is an object with a data property. This is standard across all queries that you'll make against GraphQL. It's just a way of wrapping your response. It's assigned an object with a user property, and you'll notice that this property matches the field here on the left hand side. So you can see that it's starting to form the shape of the query. However, the value of it is null. And that's because we haven't defined a resolver for this field yet. So now it's time to write a resolver that can get the value of this field for us. To do that, we have to make a change here in this object called resolvers, which is passed into the constructor. A resolver function can get the data for a single field in any way it wants. For example, fetching data from a backend API, which we're going to do today, or even from a database, or even just return a hard-coded value. I'm going to add this function just above the resolvers object and then reference it in a minute. We'll call the function getUserById. To reference this function, what we have to do is use this object as a way to say where this resolver belongs. The resolver is going to be a resolver for this field here, user, which is inside the query type. So let's type query first. And then here we're going to write user. This is where we place the reference to the function. Now the main thing we have to keep in mind is that it needs to return a value that conforms to the type user, because of course the user field maps to the user type. In order to do that, we're going to have to write some logic and return something that conforms to that type. Let's begin writing some logic to make a request to the user service for a particular user. The first thing we need to bear in mind is we don't know what the ID that's being passed in the query is yet. So how do we get that? Resolver functions can receive up to 4 optional arguments. The first one is called the parent, which we won't be using just yet. And the second one is the query arguments. This query arguments value is an object that represents the arguments for the field. So essentially this object here will have an ID property inside it. And in our case, the ID value will be this here. So the first thing I'm going to do is destructure the ID from the args object. Now that we know the ID from the query, I can make a REST request to the user service for that user. I'm making a GET request using the Axios GET function to localhost 5002/users/ and then I've dropped in the ID from the args object. I'm using await here, so I need to make sure that this is an async function. And then I'm destructuring the data property that comes back from the request, and I'm actually just going to rename it to user so that we can return that and know exactly what it is. So at this stage, with a request to the user, I'm going to get back an object with ID, first name, last name, and post. And for the most part, this part of the object here, ID, first name, and last name, corresponds to the type user, which is quite good. Obviously, the value is the right type, which is a string or ID. And then there's a bit of a problem here for posts. In our schema, we've told our API that it's going to be an array of the post type, which includes an ID, title, content, and read time. But the user service isn't as sophisticated as that. It's only returning back an ID for each post. So we're going to have to add some additional logic to this resolver so that the post value that we return corresponds to the post field and its type. For now, I'm going to add a return statement here that just returns the user. We're going to have to change this slightly in a minute. Given that we have a user object back from the user service, let's do a map over the post IDs. And for each element in this array, I'm going to make a GET request to the post service for that particular post. Then all I need to do now is return the post within each callback of the map function. And of course, I need to store the result of the map. Call it posts. So at the moment, this contains an object with a post property that is an array of IDs, but I'm going to switch it out for the posts that I have here, which is now an array of objects from the post service. To do that, I'm going to create a new object literal and spread the values from the user object, and then essentially overwrite the post property on this object. So instead of the user post object, I'm going to receive the array from here. So at this stage, this resolver is getting all the data we need for conforming to this user type. So let's go to the playground again and execute this query. This time you'll see that it returns a first name and last name with a value that's coming from the user service, and this is U11's first name and last name. I haven't shown you this yet, but if I add an ID here, it will return that, and it will also remove fields from the response if I take them away from the query, so you can see there's no first name in the response. Then if I want the post, I can add the post field here, and because it maps to the post type, I have to open curly brackets and specify what fields in that type I want. I'm going to ask for the title. And now we can see that it returns a post field in a response with an array of objects that have a title property, and the value is coming through as well. And of course I can add the ID as another field, and it'll come back in the response too. Okay, that's great. We've got a resolver for the user field, and it seems to work. But there is one hidden problem here, and I want to show you that using the messages to the services down here on the bottom left hand side. And execute this query. You'll see that it makes a request for the user, and then a request for post11, P44, and P22. And this is totally fine for a query that requests for the post on that user, because that user has 3 posts. But if I remove this portion of the query and don't request anything about a post and execute the same query, let's just create a little bit of space here, you'll notice that it still makes a request for the post as part of this resolver. And that isn't really optimal. The post service is getting hit for absolutely no reason, which is not really performant. So we're going to have to make a change here to avoid making requests to the post service when the query doesn't really care about the post values. To do that, we're going to essentially add another resolver function. And instead of resolving the posts as part of the user query, we're going to add a resolver for the user post field specifically within this object. First of all, I'm going to create that function, and we'll call it getPosts by parent post IDs, and we'll reference it down here in this resolvers object. Essentially, we just need to mention the user type in the resolver object, and then list the post field. Underneath query, let's type user, and then within an object type posts, and here's where we can reference this function. Now, I mentioned earlier that resolvers receive 4 optional arguments whenever it's resolving a field. The second one is the arguments from the query, but the first one is actually the parent value. So what this means is whenever a field like post lives as a child on a type like user, it has access to the resolve value for the user. So whenever we're resolving this user type with this function here, the return type is available to a resolver for a field within that type. So in our case, this parent argument will be the return type of this resolver here. So rather than returning the array of objects, we could return the array of IDs that come from the user service. And then within this function, we can access that array of IDs and do this logic within this function. So let's do that. First of all, I'm just going to add a little bit of space here. In this function, we're going to receive that parent object and we're going to destructure the post property from it. And I'm just going to rename it to post IDs. And of course, we need to remove this logic from here. And we'll just return the actual user instead now. And we can delete this here. So bear in mind that the user here does have a post property, but it's an array of IDs. And then essentially this response is coming into the parent and I'm destructuring it and also renaming it to post IDs. So now if we update this portion here and actually map over the post IDs, for each one we're going to make a request, and then we have this array of objects that we can return from our resolver. Okay, so I think that's us ready to go now again. So I'm just going to create a little bit of space here, and we'll start off with a query that requests posts. And you'll see that it returns a post property and a response with an array of objects with title. And then you'll see down here that it makes a request for that user, and then it also made a request 3 times to the post service for each post. But if we drop this from our query and create a little bit of space again, execute the query again, you'll see that it just makes a request this time for a user. Great, so essentially we've avoided overfetching something like the posts from the post service in this particular example. It means that whenever the client is making a request, we're not overloading services whenever they're not required, and we're only hitting the services that are necessary. So I think that's us for this demo. Thanks very much for watching. I hope to have another video up soon that talks about mutations. In this demo we just covered queries, but mutations are basically a way that you can update data via GraphQL. And also I want to cover data loaders, which is a way of batching requests to endpoints from your Graph API to the REST services or to a database. It's basically a performance enhancement. So yeah, thanks for watching. If you liked this video, please give it a thumbs up. Leave me any comments with any questions you have or feedback that you might want to give me. But yeah, thanks for watching and all the best.